If we want to go from moles to particle, representative particles, we just follow the roadmap. And what does this mean? It means multiply. Now let's just instinctively look at this. If we had 1 mole, and I'll use MOL or MOLE, doesn't really matter. 1 mole of carbon. How many particles are in 1 mole of carbon? Well, we should know, and we should just, in our head, say, well, that's 6.02 times 10 to the 23rd carbon atoms. Okay, so we should be able to just, in our head, do that. But if, let's say, we can't just figure that in our head, we can just multiply using that roadmap. We're going from mole to representative particles, atoms, etc. So we're going to multiply by this. We're going to just use dimensional analysis. So 1 mole of carbon multiplied by 6.02 times 10 to the 23rd over 1 mole. And that just cancels out. And we get that, 6.02 times 10 to the 23rd, of course. What if we said 1 mole of helium? 1 mole of helium is the same thing. It has 6.02 times 10 to the 23rd helium atom. 1 mole of, you pick anything. 1 mole of hydrogen has 6.02 times 10 to the 23rd hydrogen atoms. 1 mole of nitrogen has 6.02 times 10 to the 23rd nitrogen atoms. How about 1 mole of water? How many particles are in 1 mole of water? Well, it's 6.02 times 10 to the 23rd molecules of water are in 1 mole. Okay, so it doesn't matter what it's made out of. It's still 6.02 times 10 to the 23rd molecules of H2O. 1 mole of sodium chloride equals 6.02 times 10 to the 23rd formula units of sodium chloride. Let's say we had 2 moles of helium. How many atoms? Okay, how many atoms is 2 moles? Well, we should be able to just do that in our head. If not, you can just go to the roadmap. We have moles. That's what we're given, and we follow the arrow. We want to go to representative particles. We just multiply 2 moles over 1, multiply it by 6.02 times 10 to the 23rd atoms over 1 mole. And again, you could probably do this in your head. So 2 times 6.02, that's 12.04 times 10 to the 23rd atoms, or 1.204 times 10 to the 24 atoms. How many molecules are in 3.5 moles of water? So if we had 3.5 moles of water, how many molecules is that? Well, we just do the roadmap, 3.5 moles. It's just dimensional analysis. It's one reason why we did so much of it at the beginning. Over 1 mole. And again, I'm just taking the E off. You don't have to. 6.02. That equal, or 2.107 times 10 to the 24th molecules of water. Let's look at one more. If we had, say, 0.21 moles of sodium chloride, how many formula units would that be? Just again, take our roadmap, HCl, so we want to label everything, put it over 1. We can multiply it by the conversion factor, 1 mole on the bottom, 6.02 times 10 to the 23rd on top, and we can say formula units, and that would be 1.3 times 10 to the 23rd formula units of sodium chloride, and we want to use sig figs on this. Now what if we want to go from particles to moles? Say if we had a certain number of atoms, how many moles would that be? Well, let's look at our roadmap. Now, so we start at particles here. Again, atoms, molecules, formula units, whatever, footballs, basketballs, and we want to go to moles. And we will want to do that a lot because our mole is the way we go to other things. And we're just going to multiply it. So all of these things are multiplied. Everything here is multiplied. Multiply, multiply. You're going to multiply anything here. Multiply. So that means we're going to take this and multiply it by 1 mole over 6.02 times 10 to the 23rd particles to get moles. And we see that that's on top, moles on top. So let's give that a try. So we're doing particles, 2 moles. Let's say we have 3.05 times 10 to the 23rd moles of, let's do our, how about neon this time? And that equals how many, I'm sorry, not moles, atoms of neon, how many moles of neon? Okay, well, we take that number, 3.05 times 10 to the 23rd, put it over 1, so that's atoms. Write down what you're using. Multiply it by that conversion factor, and that was 6.02 times 10 to the 23rd atoms over 1 mole, and we get 0.507 moles. So again, we're using of neon, we're using sig figs here. There's 3 sig figs here, 3 sig figs in the answer. What if we have particles to moles again? How about 1.5 times 10 to the 24th molecules of sulfuric acid? How many moles of sulfuric acid? So really, if you've noticed, up to this time, we haven't even needed to look at the periodic table. And you don't, because it doesn't matter. Moles to molecules or moles to particles is really just the same thing for anything. It doesn't matter what you're doing it for. A mole is a mole. Now when we get to grams to moles, then we're going to definitely need the periodic table. But otherwise, it doesn't matter, because I could have 1.5 times 10 to the 24th molecules of zirconium or lactanium or kryptonium. It doesn't matter. We'll still get the same number of moles. So let's look at this. 1.5 times 10 to the 24th molecules. We're going to use our conversion factor. And if you want to use the railroad tracks, you can do that as well. You will be probably doing that when we get to chapter, later in the chapter as well. But so 1 mole of H2SO4 is 6.02 times 10 to the 24th molecules, and this really should go over here, H2SO4, but it all comes out the same regardless. We multiply it across. That equals 2.5 moles of sulfuric acid. And that does make sense because, oh, I'm sorry, this should have been 23rd. And actually, that's what I put in the calculator. This is actually 15 times 10 to the 23rd. And if you look at 6 to 15, that's about 2.5 times that amount. So if you get some weird, really weird number that doesn't seem to make much sense, then you've done something wrong. Let's just try this one. Now, let's say we just had 150 atoms of mercury. How many moles of mercury would that be? Well, let's look at the 150. We know it's going to be extremely small amount because it's not even, this is 1.5 times 10 to the 2, and we're looking at 1 mole being 6.02 times 10 to the 23rd. It's going to be very small. But let's try this over 1. So 1 mole is 6.02 times 10 to the 23rd atoms. We cross those out. We're left with moles. So we just have 150 divided by 6.02 times 10 to the 23rd. So that equals 2.5 times 10 to the minus 22 moles. So a very small amount, and I don't know what's going on here, a very small amount of mercury, just 150 little atoms.